Hi guys, welcome to the channel. I am Neeli, currently studying at Sri Venkateswara College of Engineering, Bangalore, pursuing my BA in Computer Science and Engineering. In this video, we will solve a simple problem on projecting planes from the course of Computer Aided Engineering Drawings. Let's start solving without wasting any time. I am using Solid Edge software here. This is version 19. Let me open the drawing sheet. Here we are. We'll first set up the sheet size to A4 and then unshow the background. Save defaults. Okay. Then we will fit the sheet to the screen. Now I'll select text option and type the question here. So here is the question which says a circular lamina of 50 mm diameter rests on HP such that one of its diameter is inclined at 30 degree to VP and 45 degree to HP. Draw its top and front views in this position. The very first step is to make the XY line. Go to line and select the thickness 0.35 mm and draw a line. Now go to text and mark the point as X and the extreme right point as Y. The space above the XY line will be VP and below the XY line will be HP. Now, according to the question, we have to make a circular lamina of 50 mm diameter. Go to circle and select circle by center point. Change the thickness to 0.5 mm and set the diameter to 50 mm. Place the circle on HP. Now we have to divide the circle into 8 equal parts. For that, go to line and select 0.13 mm thickness. And to divide the circle into 8 equal parts, follow these steps. Select the center point. Give the angle as 45 degree. Similarly, select the center point here and give the angle as minus 45 degree. Now go to extend to next option and extend these lines. Now mark all the points. So we have successfully completed the first top view projection. Now to make front view projection, we will have to project all the points to XY line. So go to line and project all the points till XY line. Change the thickness to 0.5 mm and join the extreme left and extreme right points. Now go to text and mark the points. When the observers observe the circular lamina from this direction, it is seen that the point P is visible and point H is hidden. So every hidden point should be written inside the bracket. Similarly, here point C is visible but G is invisible. Point D is visible here and F is hidden, and this will be point E. Using smart dimension, show the diameter here. So this is the first front view and top view projection. To make second top view and front view projection, it is important to note that whenever the inclination with respect to VP is given, the projection of the lamina will always on HP. Similarly, when the inclination with respect to HP is given, the projection of the lamina will be on VP. So according to the question, the lamina is inclined at 45 degree to HP. For that, we will select this front view. Press on the control button of your keyboard and select these lines too. Now go to move option and select move and copy option. Click on point A and move this projection to XY line. Now select rotate option and select point A and point E and give the rotation angle as 45 degree. Enter. Now display the angle 45 degree. Select the perpendicular option and make all these lines perpendicular to XY line. Select this. Now go to line and extend all the points towards right. Now extend all this line using extend to next option. To join all these points, go to circle option and select ellipse by 3 points. Select the extreme left and extreme right corners and draw an ellipse like this. Select the ellipse and change its thickness to 0.5 mm. Mark all the points. To draw further projections, we need to split the inner lines of this ellipse. For that, select the split option, zoom to this area and split the inner lines. Select the line and split. Here you can see the line is split into two parts. Similarly, follow the same step and split all the lines. Here you can see in the question it is given that one of its diameter is inclined at 30 degree to VP. Thus, it is a beta angle problem. Now, how to identify if it's a beta angle problem or not? So it's very simple. If the inclination of diameter or diagonal of a lamina is given with respect to VP or HP, you can consider it as a beta angle problem unless and until any other information is specified. To find out the beta angle, follow these steps. First, draw a 30-degree line. Give the angle as 30. Select the point and make a line. Show the angle here. For beta angle, measure the length of this line, 50. Now go to arc and select any reference point on 30-degree line and give the radius as 50 because you got the diameter length of first front view projection as 50. Now cut the 30-degree line with an arc. Select trim option and trim one part of the arc. Go to line and select line type as locus and then make a locus from this point. Now go to smart dimension and measure this length. We get the length as 35.36. Now again select arc by center point and from the same reference point cut an arc to the locus with a radius of 35.36. Now cut the locus, select line and make a line from this point to XY line such that it passes the reference point. Now measure the angle 45 degree. So 45 degree is the beta angle. In between you can trim all the unwanted lines using trim option. Now we have to incline this projection to 45-degree line. So for that select the lamina, select move option and select point E or point A. Place it on 45-degree line. Now rotate it. You can see if the points are connected properly or not. To draw the last projection, extend all the lines in upward direction. Now we have to connect all these points. For that we will select curve option, zoom this area and connect all the points one by one. This is our point A. Click on it, select next point and follow the same procedure for each point. Check whether each and every point is connected properly or not. So every point is connected properly. Now select this projection and change the thickness to 0.5 mm. At last mark all the points. Now go to leader and show the direction of the lines. To display the beta angle, go to text, change the font to symbol and press B is equal to 45. So yes, that's it. We have successfully completed this problem. Thank you so much for watching. I hope you found the video helpful.